Hello, in this video, let's look at the derivative of a function. So this is the first video on the derivatives, and we will look at where the definition comes from. And the definition for the derivative comes from the formula for the difference quotient. The difference quotient, as you recall, is the formula that allows us to find the slope between any 2 points. The first point is x. The second point is some distance h away from the point x. So this is h from here to here. And so the next point is x plus h. And using the formula for the slope, which is y2 minus y1 divided by x2 minus x1, renaming y2 as f of x plus h, that's the y2, minus f of x, that's a y1, divided by x plus h minus x, where the x is cancelled and we get h. So this formula, the difference quotient, finds us the slope between any 2 points, no matter how far they are apart. The derivative is the slope at one point. Now, at one point, there is no slope. If I ask what is the slope at this point, that question has no answer, because in order for us to find the slope, there has to be 2 points, not 1. And so to find the slope at one point, we use the idea of a limit. And so here is the definition for the derivative, which as you can see, is exactly the same formula. This is the same formula as the difference quotient. The only thing that separates these two formulas is the derivative has in front of it limit as h goes to 0. So as this distance shrinks to nothing, this point gets closer and closer and closer to our original point, which means when h is 0, we are at the same point. And so we are now looking at the slope at one point. Another name for the derivative is slope at a point, and also instantaneous rate of change. Instantaneous means at a point. So at a given point in time, how fast are we going? So the derivative can be used to compute the instantaneous rate of change. Now let's use the definition to find the derivative of x squared. And the derivative is abbreviated as the function with a little prime. This little tick mark indicates that we're dealing with a derivative of a function, not its original. So let's use the definition to find the derivative of the x squared. Now, we have already computed the difference quotient for the x squared in a different example, but let's do it from scratch. So first we will have the limit. So let's go limit as h goes to 0, and we need to find f of x plus h. Now, we know what f of x is. F of x is x squared. Now, what is f of x plus h? That means replace x with x plus h. So if we take the function x squared, and in place of x, we put in x plus h, that would be f of x plus h. Now, minus the original function, which is f of x, that's x to the 2, and then divided by h. Now at this point we can multiply out x plus h times x plus h, as we have done in our previous example. We also can notice that this is the same as difference of squares. And if we use the difference of squares formula, that's just a different trick to solving this, we can expand it or factor using a minus b and then a plus b. So if we apply this to our formula, we will have a minus b and then a plus b divided by h. So the limit is still here as h goes to 0. Now here the x and the minus x cancels off, leaving us with h times x plus x, that's 2x plus h, divided by h, as h limit as h goes to 0. Now h is cancelled off, leaving us with limit as h goes to 0 of 2x plus h. Now as h turns to 0, this piece goes away and leaves us with just 2x. And that's the final answer to the derivative of x squared. And whenever we are asked to use the definition to find the derivative, we have to use this formula. And this is just one example of how to use it. Later in the different videos, we will have formulas that are based on this process, but they summarize the process in a shortcut formula and allow us to simply look at this example and know that the answer to the derivative will be 2x. And we will discuss those formulas in a different videos. For now, this is it. This is the introduction to the derivatives. And if you have any questions on anything, please let me know. Thanks for your time. Take care.